chapter once. Okay, ask me if you have any doubts. Otherwise, we'll start a new chapter, 3D. Okay. Okay, done everyone? Any doubts for probability?
No,
No,
sir.
sir.
Okay, so we'll start 3D. Okay, in class 11th you did your basics of 3D. So what is 3D? Very simple. In 2D what we did is there were two axes, X and Y. Okay, but here we'll have three axes, X, Y and Z. All right.
Yes, sir.
And and why we needed third axis? Because the world revolves in 3D, right? Nothing is 2D object in this world. No matter what you take, it is always a 3D object, right? So we are going to study all the shapes and figures in 3D. That's all. So in 2D, whenever you need to draw a line, you needed a slope and a point and so on, right? Yes or no?
Yes.
So what we do in 3D is we replace slope with direction cosines. Okay, just as slope shows you the direction of the line, direction cosine shows the direction of line in 3D. Okay, cosine means it's the cos of that angle, and direction means it shows the direction. Okay, so if a line makes angle alpha, beta, and gamma with x, y, and z axis, then cos alpha, cos beta, cos gamma are called direction cosines. Okay, I'll be writing DC, so please understand that. And this direction cosine also denoted as cos alpha is known as L, cos beta is known as M, cos gamma is known as N. Okay, so if this is a line, and remember this line is coming out of the space, all right, it's not 2D. With x-axis it's making alpha, with y-axis it's making beta, with this it is making gamma. Okay, note it down. All right. If a line makes an angle 90 degree, 60 degree, and 30 degree with the x-axis, y-axis, and z-axis with positive x, y, and z-axis, find its direction cosines. Okay. All right, Zaina. Rishita, Sufyan, what the answer?
Yes, sir.
Okay, alpha is 90, beta is 60, gamma is 30. So cos 60, cos 90, and cos 30, right? Very easy. Second question. Find the direction cosines of x, y, and z axis. Okay. Got the answer, everyone?
Yes, sir.
What is the direction cosines for x-axis?
100.
Absolutely correct. And y-axis?
010.
Very good. And z-axis?
001.
So remember, this is very important. Okay. One very interesting thing about this is, note it down, that if you square them and add them, then it is always turning out to be 1. Whenever you add the direction cosines by squaring them and adding, you always get 1 as the answer. Okay. How we can prove that? Suppose we have a line. Okay. There is a line and it is making alpha, beta, and gamma. Okay. And this coordinate here is x comma y comma z. That means this length is x, this is y, and this, if we draw a perpendicular like this here, this much will be z. Yes, you can imagine the axis and the length.
Yes.
Okay, so I can write that r vector. Okay, suppose this is r vector will be x I cap, right? In x direction you have to move x coordinate. Yes or no?
Yes,
to
sir.
reach this point, you have to move x in x direction, y in y direction, z in z direction. So y j cap plus z k cap, right? We did this in vectors. And suppose in this triangle, let's name this. This is origin O, this is P, and this is M. So in triangle OPM, we know that cos alpha will be how much?
$45.
How do we know 45? Cos alpha will be base upon hypotenuse, right? So we can say OM upon OP. Yes?
Yes.
Yes, sir.
So I can write x upon mod r. Yes?
Yes.
So what we can reduce from here, x is mod r cos alpha. Okay? Or we can say x is, this is L mod r. Same way, we can use different triangles and find that y will be m mod r and z will be n mod r. Yes or no?
Yes, sir.
So,
And we know that mod r is always how much? Under root x square plus y square plus z square. We did this in vectors. Yes or no, everyone?
Yes, sir.
yes.
So we can square both sides. So we'll get this is x square plus y square plus z square. If we replace x as L mod r plus y as m mod r plus z as n mod r, and this is mod r square, then mod r square will be cancelled. And finally what you will get is L square plus m square plus n square is 1. Yes or no?
Yes, sir.
Okay, note it down. In fact, try to draw the diagram by yourself and try to do this proof by yourself. Okay, if needed, then you can just look at it. Otherwise, just try to figure this out on your own. Done, everyone?
Yes, sir.
Yes.
Okay. So this is all direction cosines. Okay. Then we have direction ratio. What is the difference between them? Nothing. Okay. See, direction cosine is the angle, the cos of angle, right? And cos is always between -1 to 1, right? We remember this. So the value of direction cosines are always like 1 upon root 2, root 3 by 2, and some fractions and other values. So what we do is, to make it simple whole numbers, we use something called direction ratio. Okay. So we multiply each direction cosines with a single constant to make that simpler. All right. That is what direction ratio is. And this makes our life way too easy. How? Suppose we have a line, let r is equals to, or we have a point, r is equals to ai cap plus bj cap plus c k cap. Okay. This represents a point that you have to move a distance in x-axis, b distance in z-axis, and c distance in z-axis. Yes.
Yes, sir.
So whenever you write a point like this, remember this a, b, c are direction ratios. Very simple. Okay, whenever you write down a point, the coefficients of I, j, k will be the direction ratios. And remember, direction ratios are proportional to direction cosines. Okay. A directly proportional to L, B directly proportional to M, C directly proportional to N. So A will be equals to KL, B will be equals to KM, C will be equals to KN. Very simple. Okay, and we know that L square plus M square plus N square is equals to 1. And remember, this is a very special property, and sometimes they will ask you to find the values of L, M, and N, and you have to remember this one. They will not provide you this formula. So you can use this whenever you want. All right. So L, M, and this square is equals to 1. L value, what we can write?
Sir, all the direction cosines are multiplied with the same constant to turn into direction ratios.
Yeah.
Okay, sir.
Okay. So just to make it a simpler thing, I can also write in the reverse process that L is equals to some lambda times A, right?
Yes, sir.
And same way M is equals to some lambda times B, N is equals to some lambda times C. Okay. And we replace this value here. So what we get is lambda A whole square plus lambda B whole square plus lambda C whole square is equals to 1. So we get A square plus B square plus C square times lambda square is equals to 1. Okay. So lambda square is 1 upon A square plus B square plus C square. So what it means is we have lambda is equals to plus minus 1 upon root A square plus B square plus C square. Okay.
Yes.
So what does it give us? It means if you have A, B, C, because if you have been given a single point, that means you already have A, B, C, right? If you have been given R, then you have A, B, and C, which are direction ratio. And somebody asks you what is the direction cosine, then how you can find that? Lambda times A, lambda times B, lambda times C, and what is lambda? 1 upon under root A square plus B square plus C square. Okay. So this way you can find direction cosines from direction ratios. All right. Note it down, very important. Okay, done.
Yes.
All right. If a line has direction ratios 2, -1, -2, find the direction cosines. All right. So very easy. Find the direction cosines of the line passing through 2 points -2, 4, -5, and 1, 2, and 3. Okay. And hopefully you guys know how to a vector from here to here. Okay. Solving it, everyone.
Yes.
All right, Zena. Okay, suppose this is point A and this is point B. So AB vector we know is this minus this, B minus A, right? So 1 minus minus 2, 3 I cap, 2 minus 4 minus 2 J cap, 3 minus minus 8 K cap, right? So AB mod will be 3 square plus 2 square plus 8 square root. So 9 plus 4 plus 64. Okay. This is clear, everyone?
Yes.
Yes, sir.
So
Yes, sir.
these are the direction ratios, right? A is 3, B is -2, and C is 8. So I think you can very easily calculate this direction cosines, right? 3 upon root 77, -2 upon root 77, 8 upon root 77. Okay.
Yes.
All right. Equation of line in space. Type 1. Equation of line passing through a point and parallel to a vector. Okay. Remember, in 3D, we always need a direction vector and a point to find the equation of line. Okay. In space means in 3D. All right. So first we'll learn the vector form. Then we'll learn the Cartesian form. So suppose this is X. In books, you will see that they are showing this is X, this is Y, this is Z. Okay. So I'll try to make that compatible with the books. Suppose this is A vector, this is B vector. All right. Or this is A vector, this is R vector, and we have a B vector like this. Okay. And they are asking find a vector or find a line which is parallel to this B vector and passing through this A. All right. And the line is L. Understood? A line passing through A and parallel to B vector. Okay.
Yes, sir.
So remember this R vector. What is this R vector representing? This R vector is representing the collection of all the points on line L. Okay. Just like in 2D, we wrote the equation as x plus y is equal to 3. X and y are infinite values, right? Whatever value you put, you get infinite values out of that. And that makes a line, right? Infinite points. Same way here, the R vector is the collection of all the points that represent this line. Okay. So A vector is given as position vector of a given point A, and B vector is the vector parallel to line. Okay. All right.
Yes, sir.
So remember, in 3D, you always have to remember these things, that to make a line, you have to first understand what is the line parallel to that and a given point. Okay. Everything will revolve around that. Suppose this is the point R. Okay. We need to find AR vector or AR line. Yes or no?
Yes, sir.
And AR we know is R vector minus A vector. This we did in vectors. Yes or no?
Yes, sir.
And we also know that AR vector and V vector are collinear, right? So I can write R minus A vector is equals to lambda times B vector. Yes. So R vector is equals to A vector plus lambda times B vector. Note it down.
So what's the heading?
All right, so this is the equation of line in vector form in space, where A is the point passing through, okay, and B is the line parallel to the given line. So what is lambda? Lambda has different values. You put different values of lambda and you get different coordinates. Yes?
Yes.
Yes.
So what does it mean? R represents the collection of points. Okay, so R vector is nothing but the position vector of a point which exists on the given line. So when you put different values of lambda, you get different points, and when you collect them, that becomes the given line. Okay? Nobody is confused about this? Yes or no?
Yes.
So in Cartesian form, what is Cartesian form? Everything will be writing as x coordinate, y coordinate. So let's say
Can
A vector.
you, sir, can you differentiate between R vector and A vector in the vector form?
Yeah, absolutely. R vector is nothing. This is the general. You will never see R vector as something. R vector, uh, compare this with this. Y is equals to 3x plus 5, or y is equals to mx plus b. What is y and x here?
Different points.
Yeah, but they are always written as y and x, right? You put different values of m and b, you get different lines, right?
Yes, sir.
So same way here, r vector and lambda are just the general format to represent the line. A and b will be given to you, just like m and b are given here.
Okay, sir.
Got it?
Yes, sir.
Okay. So let's say A vector, which is the point, the position vector is given as x1 I cap plus y1 j cap plus z1 k cap. Okay, and b vector, which is the parallel line, is given as ai cap plus bj cap plus c k cap. Okay, and r vector, this will be xi cap plus y j cap plus z k cap. Okay, because this will be general x y z. Yes, just like in this line, y and x are given as it is in the line. Here also it will be x, y, z. Yes or no?
Yes, sir.
Okay. So we know in vector form, the equation of line is r vector is equals to a vector plus lambda times b vector. So we can just plug in the values, which is xi cap plus yj cap plus z k cap is equals to a vector is x1 I cap plus y cap plus z1 k cap plus lambda times b vector is ei cap plus bj cap plus c k cap. Yes.
Yes, sir.
All right. So let's bring this to this side. So we'll have x minus x1 I cap plus y minus y1 j cap plus z minus z1 k cap is equals to lambda times ai plus bj plus ck. Yes.
Yes, sir.
And when two vectors are equal, we can compare the coefficients. We can say x minus x1 is equals to lambda times a, and y minus y1 is equals to lambda times b. Z minus z1 is equals to lambda times c. Okay. So from here we can say x minus x1 upon a is equals to lambda, or y minus y1 upon b is equals to lambda, z minus z1 upon c is equals to lambda. So all three are lambda. That is why we can say all three are equal. So this is the equation of line in 3D. Now I know you must be confused a little bit. Everyone is, that how is this a line now, like 3 equals 2. But just compare it to this. When we have two x's, we write y is equals to some x, right? So when we have three coordinates, we have another equality. Okay. Yes or no?
Yes,
Yes,
sir.
sir.
Okay. Note it down. And remember, this is x1, y1, and z1 is the point through which the line is passing through. A, B, and C is the direction ratio of the parallel line. Okay.
Okay.
All right. Done, everyone?
Yes, sir.
Yes.
Find the vector and Cartesian form of the line through the point 5, 2, -4 and which is parallel to the vector 3i cap plus 2j cap minus 8k cap. Okay, very easy. Just plug in the values, we'll get the answer. All right, Sufyan. In vector form, you can leave as it is, right? A plus b lambda. So here, this is b vector, parallel line, right? And a vector we can write very easily, 5 I cap plus 2j cap minus 4 k cap. All right. So vector
Yes, sir.
form is r vector equals to a vector plus lambda times b vector. So just replace and get the answer. You don't have to simplify this any further. Okay. In Cartesian form, we know x minus x1 upon b equals to y minus y1 upon, sorry, a, b, and z minus z1 upon c. X minus x1 is the point which is passing through 5 upon parallel line 3. Okay. Y minus 2 upon 2. Z minus z plus 4 upon minus 8. Okay.
Yes, sir.
All right. Type 2. Equation of line passing through 2 given points. Now, if you know vectors, then you can deduce the equation by yourself also. Okay. So suppose a vector as position vector of A, B vector is position vector of point B, and R vector is the position vector of point R. All right. Suppose we have this axis and we have 3 points. Suppose we have a line like this. This is A, this is R, and this is B. Okay, we have been given 2 points A and B, and they are asking find the equation of this line. Okay, so this is A vector, this is B vector, and this is R vector. Okay, we know that EB vector will be B vector minus A vector. Yes or no?
Yes,
Yes,
sir.
sir.
And we also know that AR vector will be equals to R vector minus A vector. Yes. And because they are
Yes,
the
sir.
same line, they are collinear also. So AB vector and AR vector are collinear. So we can say AR vector is equals to lambda times AB vector. So what we can say R vector minus A vector is equals to lambda times B vector minus A vector. So R vector is equals to A plus lambda times B minus A vector. So simple. Okay. Before it was a vector plus lambda times b vector. And b vector was the line parallel to the given line. Now, when we have been given 2 points, we can figure out this vector. And this vector itself is parallel to the given line. So we just replaced b vector with b minus a vector, where a and b are 2 points. Okay?
Yes, sir.
Clear? Okay, note it down and try to find the Cartesian format by yourself. Just replace a vector with x1 I cap plus y1 j cap plus z1 k cap, b with x2 y2 z2, r with x y z, replace in the final answer and get the result. Okay? Yes?
Yes.
Yes, sir.
Okay. Okay, done, everyone?
Yes, sir.
Okay, so the Cartesian format will be x minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1 is equals to z minus z1 upon z2 minus z1. Yes or no? Or do I have to derive it?
Yes, sir.
Yes, sir.
All right, let me give you one question. Find the vector equation for the line passing through the points -1, 0, and 2, and 3, 4, and 6. Okay. Got the answer, everyone?
Yes, sir.
Okay. So R vector is A vector, so minus I cap plus 2k cap plus lambda times B vector, 3 I cap plus 4j cap plus 6k cap. Okay. And Cartesian form, x minus plus 1 upon 3 minus
Sir, isn't lambda multiplied with
sorry,
when
yes, B minus A. My bad, B minus A. So it is 4I cap plus 4j cap plus 4k cap. Okay. So y minus 0 upon 4 and k minus 2 upon z minus 2 upon 4. Okay.
yes.
All right. One more question. The Cartesian equation of a line is x plus 3 by 2 is equals to y minus 5 by 4 is equal to z plus 5 by 3. Find the vector form for this line. Okay. Done, everyone?
Yes, sir.
So here the parallel line is 2i cap plus 4j cap plus 3k cap, right? And A vector is minus 3i cap plus 5j cap minus 5k cap. Okay. So R vector is A vector plus lambda times B vector, and you get the answer. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
So any doubts till now?
Sir, how will we know if the question they're asking is of 2 points, line passing
It doesn't
through 2
matter
points or 1 point, like in this?
if you compare this. These two represent the same thing, right? A vector that is parallel to the given line, right?
Yes, sir.
So you just have to find the parallel line. Okay.
Okay, sir.
Yeah, they are not asking what are the 2 points the line is passing through. They are just saying